Hi friends, this is Naresh. In this class, I am going to explain about engineering mechanics, and today's topic is area moment of inertia of an I and T sections. In this class, I will explain how to locate the centroid and how to determine the moment of inertia of an T section and I section. These two are the composite sections. In this class, I will find the moment of inertia about this section, that is the T section, and also this section, I section. First of all, we have to know the fundamentals about centroid and moment of inertia. The centroid of a rectangle lies at where its diagonals meet to each other. So therefore the diagonals, these are the diagonals of rectangle. So this is the intersecting point. So this intersecting point is called centroid, that is center of gravity or centroid. Here gx axis, gy axis. Gx and gy axis are called centroidal axis. These axes are passing through the centroid of the rectangle. And similarly, here I am considering the reference axis, xx and yy are the reference axis. Okay, now the dimensions of rectangle is base b, capital B equal to base, height or depth equal to d, capital D. The centroid lies at a distance of base by 2 and height by 2. So similarly, the moment of inertia, area moment of inertia of an rectangle, that is a moment of inertia about centroidal gx, centroidal x-axis equal to bd cube by 12, and area moment of inertia about centroidal y-axis igy equal to db cube by 12, and the area of a rectangle equal to area equal to base into depth. From parallax theorem, the moment of inertia about base, that is x axis, and about side axis, that is y axis, ixx iyy are the area moment of inertia about reference axis. So these are the formulas. First of all, I will explain about how to locate the centroid of T section. Then after I will explain how to determine the moment of inertia, area moment of inertia of an given T section. Okay, look at the problem. Determine the area moment of inertia of an given T section. So therefore the dimensions of T section are given here. First of all, the given T section is split up into two sections, that is one horizontal rectangle and vertical rectangle. So first of all, I consider bottom vertical rectangle as section 1 having dimensions base b1 equal to 20 mm, so 20 mm base, and height or depth d1 equal to 60 mm. So the total height of T section equal to 80 mm, but I consider from here to here. So the height of a bottom rectangle equal to 80 minus 20, so 60 mm. Now I consider top horizontal rectangle as section 2 having dimensions base b2 equal to 100 mm, and depth or height of a second rectangle, that is d2 equal to 20 mm. Now I consider the reference axis, that is the x-axis at the bottom edge and y-axis at the middle section of the T section. Here the given T section is symmetric about this axis. So the values of x are 0 because the given T section is symmetric about y-axis. So there is no need to find the values of x. Okay. So you have to find the values of y only because the given entire section is symmetric about y-axis only. Now coming to the answer. First step is locate the centroid or center of gravity of the given T section. So first of all, you have to find the value of centroid. Now the area of a bottom rectangle, that is A1 equal to B1 into D1. So base into depth, that is 20 into 60. Sorry, this is wrong. But the area of a bottom rectangle equal to 20 into 60. Next, area 2 is the area of a top rectangle. Area 2 equal to 100 and 100 into 20. Please correct it. It is wrong. A1 equal to 20 by 60. A2 equal to 100 by 20. Please correct it. Now this is x-axis, this is y-axis. Now I am drawing the diagonal lines to locate the individual centroids. So C1 is the centroid of a bottom rectangle. So the centroid lies at where its diagonals meet to each other. Therefore C1 is the location of centroid for bottom rectangle at a distance of y1 from x-axis, that is y1 equal to half of the height. That means y1 equal to d1 by 2. Similar way I am drawing the diagonal lines for second rectangle to locate the centroid C2. C2 is the centroid of a top rectangle at a distance of y2 from x-axis. So therefore y2 equal to height of a bottom rectangle plus half of the height of a top rectangle. So therefore from here to here the distance is d1 plus half d2 by 2. So y2 equal to d1 plus d2 by 2. Now the answers are x1 equal to 0, y1 equal to d1 by 2 equal to 30 mm, and y2 equal to d1 plus d2 by 2 equal to 70 mm, and x2 equal to 0. Here x1 x2 values are 0 because the given plane figure is symmetric about y-axis. Okay, hence the values of x are 0. Okay. Now coming to the tabular form for determine the value of centroid xc yc. So these are the section numbers, these are the plane names, these are the dimensions, these are the areas, these are the x and y values for centroid. Igx, Igy are the area moment of inertia. So here Igx, Igy are the area moment of inertia about centroidal axis. So Igx refers area moment of inertia about centroidal x-axis. Igy refers area moment of inertia about centroidal y-axis. So the SI units for centroid is in mm, whereas the SI unit of area moment of inertia is in mm power 4. Okay, therefore from previous slide already we have discussed about formulas. So area moment of inertia for rectangle Igx equal to BD cube by 12, Igy equal to DB cube by 12. For suffix 1 refers section 1, suffix 2 refers section 2. Therefore, B1 D1 cube by 12 for section 1, that is bottom rectangle having dimensions 20 by 60. Similar way, Igx2 equal to B2 D2 cube by 12 for second rectangle, that is top rectangle. Okay. Similar way, Igy1 equal to D1 B1 cube by 12 and Igy2 equal to D2 B2 cube by 12. So these are the answers for area moment of inertia. Now I am going to find the value of xc and yc. Where xc yc are the distance of centroid from y axis and x axis, and from general expression x equal to a1 x1 plus a2 x2 by a1 plus a2, and the answer is x equal to 0 because here x1 x2 values are 0, therefore entire value x equal 0. Similar way, yc equal to a1 y1 plus a2 y2 by a1 plus a2. Okay, and substitute these values. Yc equal to 35 mm. So xc yc are the coordinates of the centroid. So in this slide I am going to show the position of centroid. So x equal 0, y equal 35 mm. In previous slide already we have discussed about these 2 points, that is the coordinates of centroid x equal 0 and y equal 35. So from reference axis x and y axis, this is the origin. From here to here 35 mm for yc. So the x equal 0 means the point lies on y axis. So therefore the centroid CZ lies on y axis. Therefore the CZ refers centroid or center of gravity of an entire T section. C1 C2 are the individual centroids. Okay, here GX axis are centroidal x axis, GY axis refers centroidal y axis. From parallax theorem or transfer theorem, the area moment of inertia about x axis, that is base, area moment of inertia about base equal to Igx1 plus a1 yc minus y1 whole square plus Igx2 plus a2 yc minus y2 whole square, and the answer is Ixx equal to 2906666.67 mm power 4. Similarly, area moment of inertia about y axis equal to Iyy equal to Igy1 plus area 1 xc minus x1 whole square plus Igy2 plus area 2 into xc minus x2 whole square, and the final answer is Iyy equal to 1706666.67 mm power 4. Now coming to the another problem, that is inverted T section. It is a second model for a T section. This is the given diagram and these are the dimensions. Now before going to solve the problem, you have to split up the given T section into two parts, that is bottom rectangle and vertical rectangle. So now I am considering bottom rectangle as section 1 having dimensions base b equal to 100 mm and height d1 equal to 20 mm. Now I am considering the vertical rectangle as a second section having dimensions b2 base 2 equal to 20 mm and height or depth d2 equal to 60 mm. Now the area of a bottom rectangle A1 equal to B1 into D1, that is B1 equal to 100 and D1 equal to 20. Therefore area 1 equal to 100 by 20 equal to 2000 mm square, and the area of a second rectangle A2 equal to base 2 into depth D2, that is 20 by 60, that is 1200 mm square. Now I am considering the reference axis at the bottom edge and y axis at the middle section of the T section. Here the given T section also symmetric about y axis, therefore the values of x are 0. Okay, the centroid lies on y axis because this is symmetric axis. So therefore you have to find the values of y1 and y2. There is no need to find the values of x1 x2 because x1 x2 equal to 0. Now I am drawing the diagonal lines to locate the individual centroids. That is C1 is the centroid of a bottom rectangle having at a distance of base by 2 and height by 2. So this is y1, x1 equal to 0 because the centroid lies on y axis. Therefore y1 equal to d1 by 2, x1 equal to 0. Now C2 is the centroid of a top rectangle at a distance of y2 equal to height of bottom rectangle plus half of the height of top rectangle, that is d1 plus d2 by 2. x1 equal to 0, y1 equal to d1 by 2 equal to 10 mm, and x2 equal to 0, y2 equal to d1 plus d2 by 2, that is 50 mm. From similar formulas, x equal to a1 y1 plus a2 x2 by a1 plus a2. So x equal to 0 because x1 x2 are the values of x1 x2 are 0, therefore x equal to 0. Similarly yc equal to a1 y1 plus a2 y2 by a1 plus a2. So therefore the answer is yc equal to 25 mm. Here x and y values are centroid values. igx igy are the area moment of inertia for T section. igx is the area moment of inertia about centroidal x-axis. igy is the area moment of inertia about centroidal y-axis, and the formulas are here. These are the answers. Area moment of inertia. Now in this slide I am going to explain about area moment of inertia about reference axis from parallax theorem, that is x and y axis. Area moment of inertia about xx axis, that is about this bottom axis. Ixx equal to igx1 plus a1 yc minus y1 whole square plus igx2 plus area 2 into yc minus y2 whole square, and the answer is ixx equal to 1626.67 mm power 4. So ixx is the area moment of inertia about base or about xx axis. Similar way, area moment of inertia about yy axis, that is this vertical line, that is Iyy equal to Igy1 plus area 1 into xc minus x1 whole square plus Igy2 plus a2 xc minus x2 whole square. Here yc minus y1 means the distance, that is a horizontal distance between centroid CZ and centroid C1. The distance between horizontal distance between centroid CZ and C1 is 0 here. Similar way, yc minus y2 is the horizontal distance between centroid CZ and C2, also 0. Whereas xc minus x1 means the distance, horizontal distance between sorry xc minus x1 is the horizontal distance, that is 0. This is value also 0, but yc minus y1 is the value is not 0, not equal to 0. So these are the area moment of inertia for T section. Now coming to the third problem, that is area moment of inertia of an I section. Unequal. This is an unequal I section having top flange. This is top flange. This is web. This is bottom flange. The total height of a I section is 90 mm and bottom base 100 mm and top base 120 mm, and the thickness of a bottom flange equal 20 mm and thickness of a web equal 20 mm, thickness of a top flange equal 10 mm. So the given I section also symmetric about y axis, so therefore the centroid lies on y axis only, and there is no need to find the values of x1, x2, x3 because x1, x2, x3 are 0. Okay, so you have to find the values of y1, y2, y3 only. So first of all the given I section is split up into 3 rectangles. So first of all I consider the bottom rectangle as section 1 having dimensions bottom base b1 equal to 100 mm and depth or height d1 equal to 20 mm. So therefore the area of a rectangle, bottom rectangle, equal to b1 into d1, that is 100 into 20, that is equal to 2000 mm square. Now I am consider this vertical rectangle as section 2 having dimensions height or depth from here to here 60 mm, because from the total height of an I section equal to 90 mm, you have to subtract the value of 20 and 10 mm from total height. So therefore 90 minus 10 minus 20, so therefore the value of height d2 equal to 60 mm and base 2 equal to 20 mm. Now I am considering the top rectangle, that is the top flange, as section 3 having dimensions depth d3 equal to 10 mm and base b3 equal to 120 mm. So these are the values. Now I am considering the reference axis, that is the x-axis at the bottom edge, and the given I section is symmetric about this vertical line. So I am considering the y-axis at a middle section. So therefore this is y-axis. A1 equal to B1 D1, that is 2000 mm square, and area 2 equal to area 2 equal to 20 by 60, and area 3 equal to base B3 into depth D3, that is 120 into 10. Now this is the reference x-axis, this is the reference y-axis. Now you have to find the values of individual centroids. So I am drawing the diagonal lines to locate the individual centroids. So C1 is the centroid of a bottom rectangle at a distance of y1, from x-axis. This is the y1. Here x1, x2, x3 values are equal to 0 because the given section is symmetric about y-axis. Therefore x1, x2, x3 equal to 0. You have to find the values of y1, y2, y3 only. So y1 equal to half of the height, that is d1 by 2. Similarly I am drawing the diagonal lines for section 2. So C2 is the centroid of a web at a distance of y2 equal to height of a bottom rectangle plus half of the height of a second rectangle, that is d1 plus d2 by 2. Similarly, I am drawing the diagonal lines for section 3. C3 is the centroid of a top rectangle at a distance of y3. y3 equal to height of a bottom rectangle plus height of a middle rectangle plus half of the height of a top rectangle. So d1 plus d2 plus d3 by 2. So these are the values to find the individual centroids. Area 1 equal to 2000, area 2 equal to 1200 mm square, area 3 equal to 1200 mm square. Now the given plane figure is symmetric about y-axis, hence the centroid lies on y-axis only. So therefore the values of x are 0. So therefore x1 equal to 0, x2 equal to 0, x3 equal to 0, because the given section is symmetric about y-axis. Please remember. Now y1 equal to d1 by 2 equal to 10 mm, y2 equal to d1 plus d2 by 2, that is 50 mm, y3 equal to d1 plus d2 plus d3 by 2, that is 85 mm. Now we have to find the location of centroid, that is xc and yc. From general expression, xc equal to a1 x1 plus a2 x2 plus a3 x3 by a1 plus a2 plus a3. Therefore x equal to 0 because the values of x1 x2 x3 are 0. So these are the section numbers. First section is bottom rectangle, second section is web, third section is top rectangle. Okay, these are the individual dimensions, these are the areas, and these are the centroid values. These are the area moment of inertia. So similar, yc equal to a1 y1 plus a2 y2 plus a3 y3 by a1 plus a2 plus a3. Therefore yc equal to 41.36, xc equal to 0. So xc yc are the coordinates of the centroids. So therefore here igx is the area moment of inertia about centroidal x-axis. Therefore from previous slides, the moment of inertia for rectangular section igx equal to bd cube by 12 and igy equal to db cube by 12. For second and third rectangle is same. Substitute the values. These are the answers for individual area moment of inertias. Here x-axis, y-axis are the reference axis, and CZ is the centroid. Here GX and GY are the centroidal axis. So GX is the centroidal x-axis, GY is the centroidal y-axis. YC is the distance of centroid from x-axis, that is YC equal to 41.3 mm, x equal to 0. Now I am determining the area moment of inertia about reference axis. From parallax theorem, area moment of inertia about x-axis, that is base, Ixx equal to, for 3 sections you have to add 3 times for individual inertias. So Ixx equal to 4778484.91 mm power 4, and similarly area moment of inertia about yy axis equal to Iyy equal to Ig y1 plus a1 xc minus x1 whole square plus Ig y2 plus area 2 xc minus x2 whole square plus Ig y3 plus a3 into xc minus x3 whole square, and the answer is Iyy equal to 3146666.67 mm4. So these are the final answers. Ixx, Iyy are the area moment of inertia for I section. Thank you.